Welcome everyone to this week's IPLD sync meeting. It's the first edition of the special Kids at Home edition. And as every week, we talk about the stuff that we've done last week and that we plan to do this week and any other things we might want to talk about. So let's see what's on the HackPad. And Blair, please put your name on the attendees list. Or remove your name if you're not there, because I pasted from past week. Cool. Yeah, I haven't done that much because I was last week. I was at a Geo conference in Germany, but one interesting item I might have is that I was talking to someone from the OpenStreetMap community, and there seem to be some download issues for if you want to download the whole data set currently, and they distribute it also currently with BitTorrent. And I thought, well, it's a perfect use case for IPFS. And then I figured out loading in 60 gigabytes is not that easy, probably. And it's interesting that the way they do the dumps, it's not a good fit for IPFS because it's probably with the current chunking we have, you end up with a lot unique data, so you don't have that good deduplication. So with a custom chunker, it might be cool. So if we would have a custom chunker for the OpenStreetMap data, it might work very well. And yeah, so I think it's a cool use case. And once we get into the custom chunking, this might be a good thing to play with. Yeah, that's all I have. Next one on my list is Rod, but he says he doesn't have anything to report. So I go on with Eric. Or do you want to still have some time to make your thoughts?
I don't think I have a ton to report this week either. It's been a chaotic week on planet Earth. I pushed a little more finishing touches on the factor. Rod brought up some interesting comments on that about how we want to export the what's called node style. It's currently exported with some very funny named structs. We're debating doing some weirder style of coding in order to make it look nicer on the output. Feedback welcome if anybody cares. Otherwise, I spent some time on a side quest looking at IPFS and how it uses IPLD and trying to consider how we can make those go more smoothly together in the future in some probably upcoming rewrites. And I think most of that isn't super relevant to this meeting, so I'll just leave it at that. I don't have a ton to say.
All right, next on my list is Michael.
Hello. So let me pull up the list real quick. Hold on. So, oh yeah, still working on this big data stuff. Reached some really interesting performance issues, particularly with Dynamo, that are like blocking a lot of forward progress. And so it made me reevaluate the entire approach to an approach that would actually avoid some of these large scale Dynamo issues. It also led me to uncover a weird corner of S3 performance where apparently S3 performance will bottleneck on a prefix. So that's where you'll find like the maximum read and write capacity is at a per prefix basis. So I figured out a way of doing block storage where we just take the hash and then make that the directory name and make that /n code. And then all of a sudden we get like performance sharded. We get maximal performance for every single block, which is great. Oh, and now my daughter is typing in the thing. So using that now and generally working on now a new approach to this whole big data collection that kind of refactors even the first stage that we were doing, but overall is actually just going to be way faster and easier. So working on that. Also made a lot of progress on DAGDB. This is surfacing some really interesting new use cases for car files where like it's sort of using a car file like a Git repo, and then every time that it does an operation, it's just replacing the car file with a new one. And so the APIs that we currently have for manipulating car files are not super well suited to this. It's like a full kind of rewrite of the entire graph every time you manipulate it. So definitely not what anything was designed for so far, but services some interesting use cases that we might want to consider going forward. So I'll be exploring those a bit more. And then also, like, I'm starting to build some of the indexing infrastructure now, and the lack of multi-block sorted data structures that we have in IPLD is going to become an issue. So at some point, we're going to have to return to those and put some more thought in. Because there's just a lot of applications that you can't build on IPLD right now without some good work there. Last but not least, all of the project it's not time for your video, Cora. It's not time. All of the project leads are being asked to do contingency planning for COVID-19. So yeah, so all of the projects are doing contingency planning for COVID-19, and so I'll be putting out a plan, you know, if I have to, if I, you know, get pulled by my daughter to go play videos for her or whatever, that the team doesn't have to stop doing work and that everybody knows who to contact. So it'll probably just be a list of the different areas of IPLD and who to contact. It won't be like, here is who is now the new me. Because I don't feel like anyone right now has enough visibility to really do that, but there's some really obvious points of delineation, like Volker on the Rust stuff and Eric on the Go stuff and things like that. So expect that plan probably today or tomorrow. And that's it for me.
All right, thank you. Next on the list, I have Chris.
Steven had a question earlier. You were raising your hand.
So I was thinking in terms of the car stuff, like this would actually be interesting as like a data store replacement, but that's from related.
Yeah, no, I mean, it's certainly not designed for that now, but it's interesting to think about what it would take to do that. And it overlaps with some of the other stuff that we're doing. Like in just recently, we were talking about how in order to do really efficient pinning, what we need to do is keep around an index of all the for each block, what does it link to and who links to it that we currently have in the data store, right? Like having that index around would allow us to do really efficient garbage collection. You want to do something very similar with car files, where you want to have like that layer of an index so that when you do the manipulation, you can see which blocks were orphaned, and if those were the only links to them, and then you can do a really efficient new write of a car file without re-encoding if you just know all the block offsets, because then you can just go, oh, these ones were orphaned, these ones were new. Now write a new one from all that old data and not do like a full re-encoded full graph manipulation. But the question is like, do we want to complicate this this tail that we've been talking about for an index to not only include links out but links back in, and not just offsets, or do we want to have that be just a scan of the entire thing and just require a scan up front? So I'll be exploring this with the current car format. I'll probably write a library at some point that tries to do this more efficiently, and then that'll surface any requirements going forward for the next version of the car format if we want to tackle this use case in the car file format.
Muted.
You're muted. You're muted.
Sorry, I've talked about this before, but like if we had like some core format, which is like not just like car, but just like block format for like storing DAGs, but very flexible. And then car is like a specific version of that. There's like a content just archive that has like a specific form. Then we can have other things built on top of the same underlying like block store kind of idea. But it's like not saying like, oh, we're changing cars, because cars would then still be like the content address archive. Instead, we have like these other mutable data structures. But I don't want to derail like this meeting for this.
No, I mean, it's getting into some interesting territory. I would say that like we've been thinking for a while now about what a storage API would look like that did a better job of this and would have information like, do we store the entire graph for this block or not, right? Like giving us an index of all the things that this links to and that link to it in the current storage system, right? So like, what are the add-ons that we need to do more efficient operations? And when I think about how to port that to different storage backends, it's like I don't see a place for a specific file format being helpful, because like if I'm doing it in S3, what I'm doing is I'm actually using like just key only storage to store like little indexes of these things and stuff like that. So yeah, so there, but it's worth like thinking about what are all the different layers here that we can build and ways that we can leverage them. So yeah, awesome.
All right. Next on my list is Chris.
Hey guys, so I got a chance to meet with Michael last week just to see how I could help the project, and basically decided to focus on providing feedback from an app developer point of view, like on usability of APIs and whatnot. So I think, as many of you know, I'm kind of working in the medical imaging space, building a prototype. So I provide a couple of issues and dialoguing actually mainly with Michael about some of those things from my point of view. But I am available to help on other things. You guys need anything, just feel free to ping me and I'll do my best to help. Also relates to my prototype. I do have like a first step working, and one thing, I don't know, yeah, so I'm getting some real world or firsthand experience with it, and at some point, I'm not sure the best way to kind of engage you guys, or like engage this team, but would like to kind of share a little bit about how that works and get some maybe design feedback in. So maybe next week, or could schedule a separate meeting. I'm not really sure and probably separate meetings. That way, if you don't want to come, you don't have to. I'll take up your time. One thing is that I need some kind of way. I was originally thinking when I approached my project to use a centralized database that would point into IPFS, IPLD. But then, the work that Michael did on DAGDB, it kind of made me think, yeah, you could actually build a database on top of IPLD and not have to have a separate kind of traditional database. And so ended up looking into OrbitDB, and I'm sure you guys have looked at it too, but it's just kind of limited. It's like basically requires everything to be in memory, so it wouldn't really be appropriate. But I think the work, I really like the idea, Michael, you started with DAGDB. It seems like it could, transition to something that could be really cool, in terms of just this hugely scalable database, and then provide that kind of search capability that is useful. So anyway, that's my update. I have a couple of questions at the end if we have time that I wouldn't mind throwing out to the group too. Thanks.
Cool. Does anyone else have any update? Peter or Steven?
Nothing from me at present.
GoIPFS 0.5.0 is being released shortly. If you have any known issues that need to get fixed, please raise them.
That doesn't include that the import-export thing didn't get merged yet, did it?
It probably will include the import-export.
Okay, because I have it on my list.
We will make sure to put in there. It's like very close.
Okay, I'll after this meeting, I'll go and have a quick review just to, yeah.
Okay, the idea there is like we want to have that for like the 5.0 launch.
Yeah.
And the next release is coming out in 6 weeks. Yeah.
Rad, I actually do not have the main PR and GoIPFS open yet. I will add you as a reviewer when it is ready to go.
Okay. Okay.
Yep.
The other, I guess it's an update. We're wanting to have a meeting some point with fairly wide audience of, well, as much as we can get, about car file use cases. Because that does seem to be the thing that we keep on coming back to when we talk about features is, okay, well, when I want to use it for this, it doesn't have this feature. And when I want to use it in this situation, that feature hurts it. So it'd be good to get an idea of the scope of what car is meant to be, or what we intend car to be used for, and then help that define the V2 feature set, because it's potentially wide open, and that's not the greatest thing. Yeah, so we'll try and have a meeting. I was hoping this week we could pull something off, but I don't know if we could put any work into organizing that. But we'll try and pull in some folks here and elsewhere.
Cool. I forgot an update because I was also, so at the conference, it was also about geo standards. And so there's this standards organization called OGC for geo standards, for open geo standards. And there is an upcoming standard, which is kind of like the basis for all the other upcoming standards. So they kind of replace their old RPC-like XML-based thing with more like a RESTful approach and JSON and everything. And currently the specs kind of like hard code HTTP into the spec. And I will open an issue and have some support from other folks that at least they say that also other protocols are allowed. I want to get this change in because the problem is that I would expect this new standard be like the core standard for the next 10, 15 years for all geo-related things in like governments and agencies and so on. So at least opening the door of having at least a way to have a content address system underneath or non-HTTP protocols. So I will work on that as well. And the chances are quite good, hopefully, to get this change in, but we'll see.
Can you drop a link in the notes about to that? That sounds interesting.
Yes, yeah, I will. Yeah.
Well, one thing that we were talking about actually, and this is more for like Stephen and Peter's benefit, but their use case is sort of interesting in that they have like a custom file format that just has a bunch of protocol buffers in it, and then inside of the protocol buffers is like
wait. This feel like Michael is talking about this the earlier problem about the OpenStreetMap thing.
Yeah. Sorry. But what it kind of surfaced is that like even Rabbit isn't going to be very good because there's some compressed data in there that introduces noise into the fingerprint. And what you actually want is just a custom chunker. And there's probably a lot of like cases out there where a custom chunker is actually what you want to write and use a lot of the time. And so just having APIs that make it easier to provide a custom chunker is probably going to be really nice to have around an IPFS. It is surprising to me how many use cases I run into where it's not like, oh, this well-known file format could benefit from another chunker. It's like, oh no, this person's crazy use case needs its own chunker actually. Go ahead, Stephen.
I do think Peter's solution will work pretty well in many use cases. It's like one of his heuristics is like find null byte boundaries, and it's just a really common thing where you pad a couple of nulls in. I don't know if this weird file chunker format will do that, but like tars do this. Pretty much everything.
Yeah, so that's one thing, and another thing is that the tool that I'm building, which will use actually car files to communicate streamingly with the Go IPFS, the interfaces to write a chunker while keeping all the other linkage and stuff like this kind of invisible to you is really small. So writing a custom chunker would be like 20 lines of Go code ideally, and everything else will be done for you.
Yeah. I mean, like I needed what it was effectively ended up being a custom chunker for this big data work, and so I had to get that working on top of JS IPFS, and it was really hard to do with the code the way that it was, and there ended up being some PRs. But now it's actually quite easier to do this, quite easy to do this. And so yeah, to some extent it's just like a tooling issue. But I'll say so. The null byte thing definitely would help, I think, with this particular protobuf case. But I have a bunch of other cases where the moment that you're compressing anything, and I'm using compression very broadly. Once you use some form of compression, you end up really screwing up all the fingerprinting, and it's just not useful anymore. And like the case that I run into before is actually JavaScript minification. Like you don't think of it as compression because you do just spit out like usable JavaScript at the end, but it turns out that like there is a level of noise that introduces and a level of like mutation that happens even on small code changes that just totally messes up Rabbit. And without like tuning it down to basically having the block boundaries be smaller than the hash size, like you don't really get a lot of deduplication.
All right, so I guess we open it up for questions. I guess so, Chris.
Well, actually related to that is kind of binary data management. So in medical imaging, the bulk of the data we're dealing is medical images, and they can be compressed in different ways. And I've actually moved away from IPFS files to store it for a couple of reasons. But one was just like we're saying, we don't have control over the chunking. And so I couldn't take advantage of deduplication that was inherent. So having control over where I chunk a file up would actually make IPFS work much better for my use case. So what I did is I've actually been storing the binary data via IPLD using the raw codec, which you guys may kind of shudder on. But the reason I did that was because of performance. So it's actually the fastest to store and retrieve from. And that's actually one kind of point of feedback is, is that really evil or is that okay to do? Because really it's just a piece of binary data out there. But the question I actually have is, it seems like there's a need or that there could be a value in having a separate schema specifically for blobs. And so we have Unix FSv2, which takes, it's kind of like a file, right? So you have a file name, you have permissions, you have some other things. But if you just want to store a blob, like my case, I don't want to actually store it as a file in Unix FSv2. I just want a multi-block blob sequence. It seems like there could be a schema which would sit on top of that even maybe Unix FSv2 could use. So I wanted to throw that idea out and see what you guys thought.
Yes, extremely yes, completely.
That's a good idea. I wrote that.
Yeah.
Oh, good.
It's sitting in the specs repo.
Yeah. I'll send you a link to it. It's called, I believe that the final name that we settled on after like 3 renames was flexible binary list. And so it's just an arbitrary length binary. And it scales from anything from an embedded byte to like just one linked byte to like nested arrays of bytes essentially. So and the goal there is so that like you don't tie the layout algorithm to the read method. So you can have a common read and then figure out better layouts in the future, and everybody can still read the old data still. And so yeah, my plan is to actually shove this in DagDB. So DagDB has this way of like, you can take special objects and then basically when you pass them into DagDB as a value, it'll create another block and then link to it. And so that block is basically a signal to say, do something special with this. So one of the things that I'm gonna have in DagDB is you can pass it in a stream, like any stream, or actually any async generator that produces binary. And it will basically use that FBL code, the flexible binary list code, to encode it as that. And then when you read it out of the database, you'll also get back a stream object, and like that's the underlying data structure that I'll end up using. So yeah, I'll send you a link to the schema for it.
It's like Brad already posted it. That's awesome. That's actually really cool to hear. You guys are, darn if I could actually contribute something, which you guys are ahead of me here. Yeah, I'll look at that because that there's a lot of things you're talking about there that I was like, I'm gonna have to. There's different ways I can do it. Okay, so given that, let's see what's my other question. Oh yeah, so just real quick. So maybe how you implement it. Did you use like the raw codec to store the binary chunks, or did you use like DAG-CBOR?
So the schema isn't specific to a codec. So you can use DAG-JSON or DAG-CBOR. You probably can't use DAG-PB because it's not data model compatible, but like, so basically you can either embed the binary in as a value, or you can link to raw blocks. So if it's really small, you can inline it basically. So the idea is that like you still have one data structure and one read method that you pass around, even if you just have embedded bytes. So you don't have to do that like union if def code like somewhere else. But yeah, and then it's just raw blocks. Like it uses raw blocks for all of the underlying data. It doesn't do the old thing in DAG-PB that we used to do where you like wrap the binary in a DAG-PB node every time.
Perfect. That's what I meant to ask, is like just storing the raw chunks in raw codec, kosher or not. It sounds like it is a reasonable use case. Okay.
That's the preferred method for sure. Yeah.
One other quick question. Hopefully this is fast. So I've been reading up on GraphSync, and I'm just trying to understand from the scope, is it intended to replace BitSwap someday? Is like one question. No, it's a separate thing.
Well, it's just not, it's not going to be good at some things and it's going to be way better at some things. So like if you had a lot of peers with the data and you had a really wide graph, you'd end up getting it faster out of BitSwap because you can get data from multiple peers at one time and it naturally kind of balances. If you look at how BitTorrent operates really efficiently with really high demand torrents, it looks a lot like BitSwap. But when you have a linear chain like we have in a blockchain, GraphSync is like orders of magnitude faster. Like, based on the depth of the graph, you're basically saving all of those round trips. So
there's a bunch of links that you have to go in order to traverse.
Yeah, whenever you have some kind of recursion case, like it is worlds better. And frankly, like even if you didn't have a recursion case, but there was only one peer with your data, you'd probably get more performance out of GraphSync too, because you have less back and forth even with the one peer. It's really just like not all that well suited for having many peers with the data that you're pulling from at the same time, because you would have to do that kind of balancing and parallelism like yourself and your own logic, and then figure out which peers to send it to.
So okay, and then in terms of just who's a good resource, I don't know if it's this team or another team to talk about GraphSync, where should I go to learn more about this?
Depends on which part. So there's if you want to know about like kind of the selector part of it, that's Eric and Tim. And the protocol part is probably Hannah and Stephen. Yeah, because the actual kind of wire protocol was written by Hannah and designed by Stephen, who just left.
Okay.
And there's no JavaScript version of any of this yet.
No, but Tim will probably, like in not too long, Tim will write the selector engine part, and then it's just a matter of the protocol work. And I've not looked at that in depth enough to know how much work that is. I don't know, Peter, have you looked at that at all?
It's currently the case that some of the wire format for GraphSync also uses protobufs, and I think everybody involved agrees that we would like to move away from that yesterday, but it needs to be done. So,
I mean, does it actually use DAG PB or does it just use protobuffer?
No, it uses protobufs. Totally.
Yeah. So, I mean, yeah, that is adding quite a bit. Like, I mean, if you're using the default block API, then you're including DAGPB anyway. So you're going to have like the protobuf library in there. So it's not really going to increase the bundle size in JavaScript to support protocol, but, and we don't have to deal with the DAGPB codec stuff. We can like just use a protobuf library that's reasonable, I guess. But yeah, that does kind of suck. That's going to be a little painful.
Yeah, we should probably just consider writing it in CBOR, because I think everybody pretty much wants to do that anyway. It might actually be easier to rewrite the Go components that currently use PB to use CBOR than it is to write the protobuf stuff even once.
I think we said that. We said that when they were designing it. We said like, please use DAG CBOR.
Yes, we did.
But I think like a lot of the early specs were done with protobuf schemas, and so I think that there was some
a mystery of the arrow of time. But I think everybody's on the same page now of well, we wish it would have been CBOR.
I haven't heard anybody defend protobuffers in like a year, so.
So I would like to jump back a couple of questions ago and add a little more vocab to your heap of knowledge, or for anyone else listening who might not have heard of these keywords before. So you asked about how to handle large pieces of binary data, Chris, and Michael talked a little bit about his flexible bytes list. Was that the final name?
Flexible byte list, I think is what it's called.
Layout.
So that is a specific instance of a more general category of solution that we call advanced layouts or advanced data layouts, or ADLs for short. I don't know if you've stumbled across that term yet, but that's the name for this whole set of things where it mostly is for addressing splitting data up across multiple blocks. But the other unifying trait here is we understand tacitly that some amount of code is needed to make sense of the reading and the writing. And so usually this is to do with splitting stuff up into multiple blocks, but it could, for example, also be used for doing encryption. Is one hypothetical use case. We have no proofs of that yet, but it's something that has been discussed and is a cool idea. At least no proofs of it that I know of. Maybe it's out there. I don't know. And so that's the general feature. You could write your own custom code to do your own custom sharding, and it could fit into that general concept of ADLs. And the thing that has made this flexible byte list thing is just one of those, which we've spec'd out with some schema that says like topologically what the data is. And then you just need a little bit of code on top in order to read or write it. And so we are hoping that that is going to be, as you were also thinking, a pretty reusable thing. And we'll probably try to drop it into the middle of Unix FSV2. And also hopefully it works great for your standalone byte needs that have nothing to do with file systems.
Yeah, I think like the good differentiator here is like everything in the data model works with just any kind of IPLD library. Like you can serialize and deserialize and read bytes and do everything. Once you hit these more advanced use cases, like I have a ton of binary that needs to be split over a tree, you're now in the land of like, okay, well, you need IPLD plus some other code. And like, that's basically what we've been referring to as advanced layout, where there is something outside of just our off-the-shelf IPLD libraries that you're going to need to be able to do it. We are still sort of figuring out how to best standardize all that stuff, but we're getting to the point where at least we're standardizing the schemas for them and then linking to several implementations that you can go pull down and use however.
All
Thank you.
right. We are hitting the half-hour mark, so I guess that's it for today. So yeah, then goodbye everyone, and see you all next week. Bye.